Hello everyone. In this video, I have prepared an infographic wherein I have taken the database of CAR DEKHO company and I have performed data processing and cleaning, data visualization, and linear regression on the same database. In this infographic, we will be discussing all this process in detail. Firstly, CAR DEKHO company is a platform wherein sales and purchase of second-hand cars is available. This service is very new to the market, wherein people were always up to buying new things, new cars, especially in the arena of cars. Now, this is a platform where people can resell their cars, and people are also ready to buy the second-hand cars. So this is why I found this database to be interesting. This database contains the car price information, the information about selling price, the information about the year in which the car was purchased, information about the kilometers driven, fuel, seller type, owner, year, and transmission, etc. In this database, we have three numeric data as selling price, kilometer driven, and year, and we have four categorical data as fuel, seller type, owner, and transmission. Now, further moving, I would first like to share how I did data pre-processing and cleaning. So firstly, after selecting the file on Orange, I selected data table and I found that there were no missing values in my data. So I further moved on selecting what all, like eliminating the irrelevant columns. So I eliminated the column number, column transmission, because I thought it was not needed for my this analysis. And for the other things, I included it on my data table by, and I did this using select columns widget. And after this process, I got the columns which I needed for this process, and I moved further. So moving on to the next point, as data visualization. Here in this process, I have prepared three graphs. First is scatter plot, second is feature statistics, and third is correlation. So here, it, through this through these three figures, I will be explaining what this data is trying to convey to us. Firstly, in the scatter plot, we can see on the x-axis we have years of the purchase of car, and on the y-axis we have the selling price. So by looking at the scatter plot, it is clearly visible that the cars which were purchased in very initial years, or for example 1992 or 1996, around 2000, they have a very low selling price because they are very old. And the car which are very new in terms of year of purchase, for example 2018 2019, have a very good selling price because obviously they are new for the market. And this can clearly be stated. After moving forward to the fourth point, we have the feature statistics. So here we have got the mean, median, dispersion, maximum, minimum, and missing values for all the columns in our database. For year, it is clearly visible that for we have cars from most of the years, almost relaying around all the years. This is can be clearly visible. This is clearly visible through the distribution of this data. Now moving forward with mean, it can clearly be stated that to we around 2013 we have the cars which were bought around 2013, the time period around 2013. And also the selling price of most of the car for us is in and around 5 lakhs. And the most of the cars in our database from the Car Dekho company have the kilometer driven around 6,000. So all these things can be captured by the feature statistics. Now, on the third graph, we have correlation. In correlation, it is clearly visible that kilometer driven and year are correlated by 0.42%. Obviously, because they have a very strong dependent connection. Kilometer driven is directly dependent on the year of purchase of car. As much as old the car is, as much as higher the number of kilometer driven will be. Secondly, selling price and year correlation is plus 0.414. Then that is also a very valid point where uh, selling price of the car is highly dependent on the year of its purchase. As old the car will be, the low the selling price will be. So they are inversely proportional. Now, coming forward to the kilometer driven and selling price. So these are correlated by minus 0.192%, and they are uh, correlated as kilometer driven will be more, the selling price will be less. So again, they are inversely proportional. Moving forward with the next point, we will be doing splitting of the data. For this process, we actually need to do this to do perform linear regression. So for splitting the data, we have to divide our data into two, where we have to take the train data and test data. So to perform the same, we first have to use data sample. We first have to uh, in the sixth point, you can see we first have to give rank to the data which I've given, and then in the seventh point, you can see I have used data sampler widget in orange to divide my data, to split my data into two. One will be my sample data and one will be my remaining data. And then I in the ninth picture, you can see that this data sampler has divided my data into two. This is train data and this is test data. And then in the further process, I have performed a linear regression. After performing linear regression predictions in test code using all these widgets, I have come with the analysis where in the eighth point you can see here R2 is 0.190. So this clearly states that all the columns, all the data which I have, all the variables which are included in the database, so there will be some independent variable and some dependent variable. So all the dependent variable are dependent on the independent variable with the ratio of 0.190. As my R2 is coming 0.190, it is clearly visible through the data. So by this we can analyze that as our target variable was price, and the other data which we had were kilometers driven, selling price of the and the year of the purchase of the car, and other categorical data we had, it is clearly visible that uh, the selling price of the car was dependent on kilometers driven as well as year of purchase. Here, year of purchase and kilometer driven are the independent variable, wherein selling price, which is our target variable, was the dependent variable. And here the linear regression says that R2 is 0.190. So by this, we come to the end of this analysis. I hope it was clearly stated, and I thoroughly enjoyed this process, and I think you enjoyed the same too. Thank you so much.